To this point in the chapter, we've been talking about carboxylic acids. We're now going to turn our attention to derivatives of carboxylic acids, and that's what we're going to spend most of the rest of the chapter on. So we'll start with an introduction to these carboxylic acid derivatives, and then also talk about their nomenclature. So in the last video, we saw examples of reduction of carboxylic acids, where we're changing the oxidation state of this carbon atom. There are a lot of reactions that carboxylic acids can undergo that doesn't change the oxidation state. If we replace the OH with an electronegative heteroatom, then the oxidation state doesn't change. And so anything where we replace the OH with some other electronegative heteroatom group, it will be a carboxylic acid derivative. And so a couple of the most common carboxylic acid derivatives, and the one that we're going to talk about, if the Z group is a halogen, and we're going to focus largely on that halogen being chloride, then it's an acid halide. If the OH is replaced by another essentially carboxylic acid group, then this is an acid anhydride. If we replace the H with an alkyl group, we have an ester. And if the OH is replaced with a nitrogen with either hydrogens or alkyl groups coming off it, then we have an amide or an amide. Now, the strict definition of a carboxylic acid derivative is any compound where carbon has 3 bonds to electronegative atoms, then it's a carboxylic acid derivative. And so the fifth type of carboxylic acid derivative that we'll talk about is a nitrile. So even though it doesn't have this carbonyl group, because I have a carbon with 3 bonds to an electronegative atom, an electronegative heteroatom, it's considered a carboxylic acid derivative. So nitriles are our fifth example. When we consider the reactivity of these different carboxylic acid derivatives, acid halides and anhydrides are the most reactive. This makes them relatively unstable, and they're not common in naturally occurring compounds. Esters and amides are less reactive, and they're very common in nature. So these 3 examples of esters all give these different fruits their characteristic flavors and smells. Amides are very common in nature, and for those of you that are biochemists, proteins are essentially amino acids linked together, and each of these amino acids is connected to the next one by amide bonds. Now, we've seen this functional group table before, and the carboxylic acid derivatives make up most of the compounds that we hadn't seen yet to this point. So we have our esters, our acid halides, our amides, and our nitriles. Because we have carbons connected to electronegative atoms, giving that carbon relatively high oxidation states, they're all relatively high in the priority list. Now, we're getting ready to learn how to name all of these carboxylic acid derivatives. We could get pretty crazy with the names by putting multiple carboxylic acid derivatives in the same compound and making you know whether to name it a substituent or a base compound. I'll be honest, I'm not going to get crazy with the nomenclature of these carboxylic acid derivatives. Basically, I just want you to know the base names and to name very simple carboxylic acid derivatives. All right, so we'll kind of go through each one. First, we have the acid halides. And so if we have a carboxylic acid, the corresponding acid halide, we just replace the ic in the name of the carboxylic acid with il halide. So acetic acid becomes acetyl bromide. Benzoic acid becomes benzoyl chloride. Okay, next we have the acid anhydrides. In this case, if we have a symmetric acid anhydride where both groups coming off this central oxygen are the same, then whatever the name of one of those acids would have been, we just replace the acid in the name with anhydride. So 2 carbons would be acetic acid. So if I have essentially a double acetic acid coming off the central oxygen, then it would just be acetic anhydride. Or acetic acid is the common name. The official IUPAC name would be ethanoic anhydride. If we have asymmetric anhydrides, right, so each essentially carboxylic acid group, if you will, is not identical, then just name each group and end it with anhydride. So just this would be acetic acid. just this would be benzoic acid. We'll put them in order alphabetically, so this would be acetic benzoic anhydride. Or if instead of using acetic, I used ethanoic, it would be B comes before E, so it would be benzoic ethanoic anhydride. Okay, in esters, we've essentially replaced the hydrogen from the carboxylic acid with an alkyl group. And so in this case, the ending, we change it from the ending to from oic to O8. So if this is butanoic acid, this part is butanoate, and then we name the alkyl group coming off just as an alkyl group. So I have a propyl group that I replace the hydrogen of the butanoic acid with, so this becomes propyl butanoate. For the amides, we take the oic acid or the ic acid, depending on the case, and replace it with amide. So acetic acid becomes acetamide. Benzoic acid becomes benzamide. Now, what happens if we have things other than hydrogens coming off of the nitrogen? In that case, we name the substituents just like we would name a substituent coming off somewhere else on the carbon chain, but as its position, rather than giving it a number that would associate it with a carbon atom, we give it the letter N. So if this was just an NH2, this would be acetamide. Because I have this methyl group coming off, it's coming off the nitrogen, so it would be N-methyl acetamide. And if there's more than one group, we just, name it as we would any other two groups coming off. So because both of these are coming off the nitrogen, it's a dimethyl, and so I have to give the position of both, so it would be NN-dimethyl acetamide. And we would put them in alphabetical order, just like we would any other group coming off. So here I have 1, 2, 3, 4, 5, 6. So the base name is going to be hexanamide, and then I just need to give the substituents. So I have a chloro, a methyl, and an ethyl. So alphabetically, the chloro comes first. That position, because it's on a carbon, is 1, 2, 3, 4. So I have 4 chloro. And then the position of both the methyl and the ethyl are the nitrogen. Ethyl comes alphabetically before methyl, so 4-chloro, N-ethyl, N-methyl, hexanamide. All right, finally for the nitriles, we replace the ic acid or the oic acid with O-nitrile. So acetic acid becomes acetonitrile. If we called it ethanoic acid, it would be ethanonitrile. Or benzoic acid becomes benzonitrile.